Engineers from the Polish startup Clone have developed a prototype of an anthropomorphic musculoskeletal robot called Torso, whose design replicates the anatomy of the human torso. The robot has 2 arms with flexible elbows and hands with fingers, a cervical spine, and anthropomorphic shoulders equipped with sternoclavicular, acromioclavicular, scapulothoracic, and glenohumeral joints. The robot's body is powered by artificial hydraulic muscles, with a valve matrix located in the chest area. The robot can move its arms as well as tilt and turn its head. Currently, engineers are training the robot's control system to perform dual-hand manipulation tasks. The goal of the project is to create a humanoid robot with a design that replicates the functionality of natural human body parts. Until recently, engineers had focused on developing a bionic robotic hand. All elements of the hand move through the tension of artificial hydraulic muscles based on McKibben actuator designs. These muscles consist of a braided sleeve containing a stretchable airtight tube. When liquid or gas is filled, the tube inflates, expanding in width. However, since the outer sleeve barely stretches, the entire actuator contracts in length, mimicking muscle movement. For example, the grip strength of Clone's bionic hand is sufficient to hold a set of kettlebells with a total weight of 18 kilograms. The humanoid robot race continues. China's Engine AI recently unveiled its first full-size, versatile humanoid robot called SE01. Developed with a focus on practical applications, this robot is designed to perform a wide range of tasks across various sectors, from industrial manufacturing and services to education and scientific research. SE01 is equipped with 12 degrees of freedom in its joints, allowing for flexible movements like squats and push-ups. This capability enables it to perform physically demanding tasks, while remaining stable and maneuverable. Engine AI, founded in 2023 and based in Shenzhen, is composed of robotics experts, many of whom have experience from top universities like UC Berkeley and Tsinghua. The company's primary goal is the development of versatile robots with potential for commercialization and broad deployment. Here is a unique training process of a large group of mini cheetah robot dogs, developed in MIT's laboratory. Each of these small robots weighs around 9 kilograms and is designed to mimic the fast, smooth movements of animals like cheetahs. Equipped with 3 powerful motors on each leg, the robots can perform complex maneuvers, sharp turns, self-correcting jumps upon landing, and even backflips. In the video, you can see the synchronized movements of 9 robots, demonstrating precise coordination and an efficient decentralized control system where each robot independently adjusts its position and adapts to changes in real time. MIT uses advanced reinforcement learning algorithms to train the robots in a virtual environment, allowing them to learn from various scenarios before deployment in real conditions. This approach minimizes human intervention, as the robots adapt independently to new conditions, like slippery surfaces, maintaining balance even in challenging situations. Limex Dynamics has developed an innovative robot called Tron, the world's first multimodal bipedal robot capable of switching movement modes based on surface type. The robot can be controlled in real time via a wireless remote or autonomously through Python programming. Standing 85 centimeters tall and weighing around 20 kilograms, it can operate for up to 1.5 hours on a single charge. Additional ports allow for the connection of various peripheral devices such as cameras, lidars, and manipulators. Tron-1's modular design enables it to adapt easily to different terrains, including uneven surfaces, smooth floors, and challenging areas with obstacles. This adaptability makes Tron-1 not just a robot but a full-fledged platform for research and experimentation, where flexibility and high maneuverability are essential. The company A-Robot has introduced its new humanoid robot named Alice V4. designed to perform tasks closely resembling human behavior. Alice V4 stands 136 centimeters tall and weighs about 20 kilograms. It features 20 degrees of freedom in its movements, allowing it to execute complex tasks with precision and smooth motion. The robot can interact with people through facial recognition, speech, and gesture recognition technologies, providing a positive user experience thanks to its friendly interface and design that promotes a robot's natural perception. Its capabilities include recognizing and moving objects, as well as analyzing its environment, enabling it to navigate a soccer field, track the ball, and even kick it, showcasing a high level of autonomy. A-Robot aims to create a robot that can become a reliable assistant, interacting with humans as naturally as possible. Very soon, robots may fully replace baristas, offering users quick, accurate, and high-quality service. One such example is the Xbot coffee robot, an autonomous barista robot capable of making a variety of coffee drinks, from classic espresso to complex lattes, in just 70 to 90 seconds. Designed with the needs of modern mini-cafes in mind, Xbot offers personalized beverages and convenience, making coffee breaks more tech-driven and accessible. The robot is equipped with an AI system and a touchscreen, allowing it to take orders, adjust recipes to customers' tastes, and maintain consistent quality. With its compact design and ability to operate autonomously, the Xbot coffee robot is perfect for high-traffic areas where fast and reliable drink service is essential. Specialists at Disney Research Labs have developed a teleoperated robot whose manipulators are powered by hydraulics and pneumatics. The robot is equipped with 2 manipulators, each with 4 degrees of freedom, and a pair of cameras mounted on a rotating head. Each manipulator uses 4 identical hydraulic cylinders, which can operate with regular water as the hydraulic fluid. The operator controls the robot using VR goggles and a special controller. According to the developers, the use of hydraulics and pneumatics in teleoperated robots allows for more precise replication of the operator's movements than using cables. In a demonstration video, the operator uses the robot to play a xylophone, move a chicken egg, thread a needle, and even play patty cake. ETH Zurich engineers have upgraded the robot Animal so that it can climb vertical ladders. They replaced the robot's standard legs with specialized C-shaped end effectors that allow it to securely grip the steps and maintain stability during ascent. However, these end effectors would be ineffective if the robot didn't know how to use them, so the scientists applied an AI-based training method. In laboratory tests, the modified Animal with its new software successfully climbed ladders with inclines between 70 and 90 degrees in 90% of cases. Moreover, its climbing speed was 230 times faster than any other bipedal or quadrupedal robot capable of performing similar tasks. Write in the comments what you liked most after watching this video. Don't forget to like this video.
It goes a little something like